Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome back to microcontroller application BNR BND35503, and in this video we're going to discuss on the topic of PWM and motor control. Okay, let's begin. Right, so before we go deeper into what is PWM or pulse width modulation on a microcontroller, let's take a brief view on what is DC motor. Okay, this is I think the first and the simplest method of adding something that is moving or something that is rotating in our systems that can affect our environment, right? So before this we just use something like LCD and LED. This just give you a simple display, but now we're going to try to control our environment using something that can move and physically change our system or our environment. Okay, right, so DC motor is the simplest way. If you know, DC motor consists of is moved by electric current and then being pushed around the magnetic field. Okay, this is something that you already learned in school or in the matriculation, right? So basically the basic concept of DC motor is what we have to know right now is just it is controlled by a direct current. So we know that direct current we have both direction, right? We have positive, negative, and then we can flip the polarity into the other direction, right? So if you change the polarity, it will change the direction of the motor. If the first one it turn clockwise, you change the polarity and it will turn anti-clockwise. So that is something that we need to know. And why? Because we're going to control this. All right, so the terms here we want control the motor using our, of course, microcontroller. All right, so another thing is that usually what other kind of rotating movement that we have other than DC motor? Yes, we have also have what they call as a stepper motor. As compared to DC motor, stepper motor we can control in terms of the position. Okay, so for example, we have we have uh, we have a DC motor here, right? DC motor, let's say we have some marker. This is a DC motor, and then this is the pole, and then it will turn this direction. Okay, so it will turn at a certain speed given a certain voltage or current, right? So it will turn with the specific rotational velocity, right? So it will turn at a certain speed, right? This is DC motor, right? So as compared to another one, we have another one is what they call as a stepper motor. Right? Stepper motor, the difference is that instead of the pole head will turn at a certain speed, stepper motor we can control where the the pole here is the position. Okay, for example, the first here is a 0 degree. Let's say we want to like turn it into some position. You want to turn it into 45 degree. Okay, so basically in your microcontroller you can feed in out your information. For example, 1010. Okay, and then there's a decoder here, and the stepper motor will turn your position into what that you are desired. Say, so for example, here is 45 degree. So that is the distinct difference lah between DC motor and also the stepper motor. Right, so in this video we're going to and both of these, okay, right, before I forget, both of these we can control using our microcontroller. Right, there's two ways that you can control the motor here. If you want to control the speed of your DC motor, you have to fit in what they call as a PWM pulse. Okay, PWM pulse ni actually it's similar to a to an analog voltage, right? For example, we wanted our motor to be fast, right? You want motor to we want to be fast, then you have to fit in higher voltage, right? You fit in with the higher voltage. If you want the motor turn slowly, right, what you have to do is you have to lower the voltage, right? So PWM, what they do is they actually fit in a square wave that contains a combination of zero and ones. This combination, if we combine it, if we calculate into average, it will become similar to what we have in a analog voltage. For example, if the PWM is 50 duty cycle, then the DC motor will receive around 2.5 voltage, whereas the maximum volt here is should be 5 voltage, right? So 25 per 5 voltage, so it is a 50% duty cycle. Okay, so we're going to discuss more on this in the next video, and how we're going to program our PIC 18F4550, and also we're going to test it in the programming, whether the concept works. Okay, right? So before we end this first part of the video, I would like to show you some of the ways that you can control a DC motor. All right, so this shows, the first one here shows unidirectional control, like we just discussed just now. We can control it either clockwise or counterclockwise, but the trick is you're going to have to change the polarity of your current source, right? DC current source. You have to flip the battery, for example, right? So another one is without having you to change the polarity, without you having you change the polarity of your current source, you actually can control the motor clockwise and counterclockwise by just changing the combination of switches. Okay, this is called a H bridge. Okay, for example, we have 4 switch here, right? By selecting right combination of switches, actually you can control this motor either clockwise or counterclockwise. Okay, for example, you look at on your left here, right? This is the first direction. You switch on switch number 1, and then you switch on switch number 4, right? So the current will flow this way, from the left to right, and then go to the ground. Make sure the switch 2 and switch 3 is open. Okay, right? So this is the first direction. So how we want to change the direction? Just flip the other way around. Okay, now if you close the switch 2 and switch 3, right, so the current will flow from the right to left. So incidentally, it will change the direction of your motor, right? So this is one of the way you can control your direction of your motor, right? Okay, right. This kind of technique of technology actually being implemented in many types of application, and nowadays we actually don't have to actually use this kind of circuit anymore. You can use what they call as a LN293 IC. Okay, what's the benefit of using this IC? If you can see the picture here, right? So instead of you have to control your switches, right? Which is you're going to waste a lot of microcontroller input output by doing that. Now if you use the L298N, okay, dual H bridge IC, you can just control it by selecting the right input here. If you can see, if you can close up here, we have input A and input B. That means we have two motor that you can control using PWM or using digital input, right? So what's the difference between digital input and PWM input? If you feed in digital input in here, right, it will turn the DC motor at full power, right? So DC motors, for example, you have like a 12 volt DC motor, right? You have 12 volt, you put in here 12 volt. If you put 5 volt in the input, the output will max out. We're going to have 12 volt output to your motor. So your motor will turn very fast. All right. So if you use PWM, right? If you put PWM input here, your motor, you can control the speed, not just the direction of your motor. Now you can control the speed, meaning that you can slow your motor a little bit down, right? Okay, so that's mean if you have PWM output from your microcontroller to this L298N, what they call this as a motor driver. If you feed that PWM signal here, meaning that you can reduce the speed, right? For example, if you put 50% duty cycle here, that is 2.5 volt input, your output of your motor, instead of full 12 volt, you're going to have just instead of 12 volt, now it will reduce to 50%. It will reduce by 6 volt. Okay, right? So that's the beauty of using L298N dual H bridge, which is I recommend you to use in your projects in order to control a DC motor. Right, so until the next video, we're going to focus on PWM or pulse width modulation in our microcontroller PIC 18F4550. Until next time, Assalamualaikum warahmatullahi wabarakatuh. See you again.